So now let's discuss distance measurement. So remember in our definition for surveying, that includes measurement of distance between points. So that is what we'll do now. So in measuring distances by use of meter tape or other instruments, we'll encounter errors. So the first type of error is your systematic error. Whenever we encounter a systematic error, we need to apply the following corrections. So we have this equation TL equals ML plus or minus C times ML over L, where TL is the true length between 2 points or true distance between 2 points, ML is the measured length, C is the correction, and L is length of tape used. So for example, there's an error or correction due to tape being too long or too short. We'll apply the following rules. So we call them slams, because if your tape is too short, when you're laying out your measurements, you have to add the correction. If it's measuring distance between 2 points, you're going to subtract the correction. So slams, tape too short, lay out, add, measure, subtract. So to illustrate that, let's say we have 2 points, A and B. Okay. And the true length or true distance between them is 1 meter. Okay. And let's say you have an erroneous instrument. For example, this meter tape. So this meter tape says that this point is already 1 meter. If we use this to measure our point A to B, okay, we'll get something like this. So if using this ruler, right, I'll do this. So reading that, our measurement would be, so this is 1 meter, these are in centimeters. So this is 1 meter plus, let's say, 39 cm. Okay. So our measured length using this ruler would be 1.39 meter, right? And the actual length is 1 meter. So this tape is too short. Our measured length is 1.39. The correction there would be this length right here, which is 39 cm. In actual, the correction is very much smaller than this, okay? I'm exaggerating it for you to see. So this is my correction. So in order to get the true length, that would be your measured length minus correction. So 1.39 minus 0.39, you'll get your 1 meter. Okay? Now, what if we measure more than 1 meter? There's going to be an error for every time you use your meter stick in this case. So that's why instead of just subtracting, since the correction will be applied every time you use your tape, the actual equation would be C times ML over L. ML over L denotes how many times you use the meter stick or measuring tape. Okay? So it's not just plus or minus C, it's plus this. And take note, this tape is too short, and see what we did to get 1 meter, we subtracted. So tape too short, when measuring, you subtract. So that's how it is. And if your tape is too long, you just do the opposite. Okay? So that's correction due to tape being too long or too short. Now, what about correction due to temperature? Remember from your physics class, your thermal expansion, thermal compression. So it's the same thing here. Correction due to temperature, we'll still use the equation alpha change in PL. So that's your change in length, right? Remember from your physics, change in length equals alpha, I think it's written this way from physics. Change in L equals alpha LO change in P. So it's the same, right? Instead of change in L, that's your correction. It's by how much your tape shrunk or expanded, depending on the temperature. So it's alpha change in PL, where alpha is, so most of the time we're using steel tape. So the alpha for that, alpha is the coefficient of temperature, 11.6 times 10 raised to negative 6 per degree Celsius. If the instrument you're using is not a steel tape, okay, alpha should be given. So depending on its material, change in T is TA minus TS. TA is the actual temperature of where you took your measurements on. TS is your standard temperature. And then L is the length of tape at standard temperature. Next, we have correction due to pull. So when you're taking or using a meter tape to take measurements between 2 points, okay, sometimes you apply too much force to pull your tape or too little force that your tape sags, and that's going to create a correction or error. So our equation is Cp for correction due to pull, change in P, L over AE. Again, I'm not sure if you've taken mechanics yet or even in physics. Remember, we have elongation due to normal force. Okay, so from mech, elongation due to force is PL over AE. This is how much your body shrunk or elongated depending on your force. So that's the same thing here, but instead of using delta, we use C over P and change in PL over AE. So change in P is PA minus PS, where PA is your actual pull, PS is your standard pull. A, cross-sectional area of tape, E, modulus of elasticity of tape, L, length of tape at standard pull. If your tape is steel, modulus of elasticity is 200 GPa. Next, number 4, correction due to sag. So this would always subtract. The previous ones, correction due to temperature, correction due to pull, it could be an addition or subtraction depending on whether it's expanding or contracting. Later on, I'll show you in our example. So here, correction due to sag, that's always subtraction. Equation is C sub Sg equals W squared L cubed over 24P squared. Now take note of this. W is weight per linear meter. It's not just weight of your tape, it's weight per linear meter. So you're going to divide the total weight of your tape over the length of your tape. So that's your W. L is unsupported length of tape. So for example, we have if we're having 2 humans or 2 people holding the tape. Okay, so this is your tape. This is the unsupported length. If we have a middle person holding the tape here, the unsupported length would be this. Okay? So that's your L for correction due to sag. And then P is the applied pull. Next, correction due to slope. So if you do your field work 2 and 3, you'll see that. If you're not holding the tape properly, again, if you have 2 people here, measuring distance between 2 points, and let's say one of them isn't holding it at the same level, instead of it being a straight line, it's a slanted line. And obviously, that won't give you the correct measurement. So that's why we have correction due to slope. And then our equation would be CSP equals H squared over 2S, where H is the difference in elevation and S is slope distance. Correction due to pull, delta P is PA minus PS. PA is applied pull, PS is standard pull. Okay, does that answer your question? Okay. You're welcome. Next. So that's it. That's all your corrections due to slope. So always subtract as well. Because if you hold your tape at an angle, this is going to give you a measurement smaller than it should be. So for example, you have distance between 2 points, right? This is your point 1, this is your point 2. Let's say the reading here is 70 cm. Let's rotate that. Let's see what happens. So as you can see, if we do this, the measurement will now be shorter. Let's exaggerate. And as you can see, 70 cm now falls here, right? So what you'll get is greater than 70. So you need to subtract the correction. That's why this is always subtract. Okay, we'll get something like 75. So subtract 5. And that's it. So for us to better understand, let's have a few examples. Ready your calculator for this. Okay. So number 1. A 30-meter steel tape, known to be 30.006 under standard conditions, was used to record a measurement of 119.898 meters. What is the correct distance of erroneous tape length? Or for erroneous tape length? So first step, let's write out our given if we can. So you have 30-meter steel tape. That's the length of your tape, or that's the actual length of your tape. So L is 30. Okay? And then it's 30.006. Therefore, what is RC? Correct, Maro. So clear. 0.006. Remember in our example earlier, our correction is 0.39. So for this, by whatever much the tape is too long or too short for, that's your correction. Our tape should be 30, it's 30.006, so the correction is 0.006. Okay? And then record a measurement, so that's your ML, 119.898. Okay, and then we're looking for TL. So looking back, our equation was ML plus minus C, ML over L. So using that, TL equals ML plus or minus C, ML over L. Let's apply, sub in our value. So 119.898 plus C, which is 0.006. Okay. So the question here is plus or minus. So what should it be? Should it be plus or should it be minus? Correct, plus. Correct. Criscal, John, Carlo, and correct. And Zaira, Ortiz, Criscal. Plus, tape is too long, right? It's more than 30. And if you're measuring, it should be subtract. Sorry, it should be add. See, too long, measuring, add. So plus. ML again is 119.898. L is tape length, so 30. Please solve what's the answer to 3 decimal places. Correct, Mark and Zaira, Villalobos, Ortiz. So true length between the 2 points is 119.922. meters. Okay, so that's number 1. Next, let's have number 2. As you can see, the answer is already here. Number 2, a tape has a standard length at 20 degrees Celsius. A line was measured at a temperature of 3 degrees. If the coefficient of thermal expansion is that, and its true horizontal length is 865.30, what is the measured length in meters? Again, first, I'm going to type in the given. So standard length at 20, so that's your standard temp as well. So I'm going to call that TS at 20. Next, measured at 3 degrees, so that's your actual temperature. And then coefficient, I'm just going to write that as 11.6 times 10 raised to 1, 2, 3, 4, 5. Or 1.16 times 10 raised to negative 5. Just to make it shorter. And then through horizontal length, so that's your TL, 865.30 meters. Okay. So your C is alpha L, alpha change in TL. Okay. So before I do that, let me ask you first, based on the situation in example number 2, will the tape shrink or expand? Correct, it's gonna shrink. Correct, Maro and Geraldine Lazaro Casople. It's gonna shrink. Therefore, your tape will be too short, so you're gonna use the equation for that accordingly. So let's solve. So 1.16 times 10 raised to negative 5. Change in T is TA minus TS. So 3 minus 20 times L. And L is what we're looking for, right? So let's see. Length of tape at standard 10. Actually, we're not looking for this, but it's not given, right? The tape length is not given. So let's just write that as L. Therefore, please compute what is this. Correct, Michael and Jasper. Viernes ácido. It's negative 1.972 times 10 raised to negative 4. And there's an L here, so L. So this negative sign just means it's gonna shrink. So you're correct, it's gonna shrink. So you can just write, therefore, or 1.972 times 10 raised to negative 4. Shrink. Okay, and then let's use our basic equation. TL equals ML, and then plus or minus. You already know it's gonna shrink, and you're taking measurement. So it's too short, taking measurement, subtract. Also, if you don't want to go that route, just follow the sign here. So minus C times ML over L. Then TL is given 865.30. ML is what we're looking for, right? What is the measured length in meters? Minus C. Since we already have the negative sign here, just apply the value. So 1.972 times 10 raised to 4, negative 4, times ML. Okay, wait lang. times L, shrink. So times L times ml over L. And as you can see, even though we don't know the measured length, it just cancels out. So we can solve for ml. What's ml? Correct? So please solve, okay? We might get a different answer from what's in your handout, so we need to check if we're doing this correctly. So correct, Angel and Jerome. Zelica Bilbuena. Angel. Zelica. So it's 865.47, correct. Okay. Next, number 3. A steel tape is 100 meters long. So I'm just going to write our given already, 100 meters. Standard pull of 65. So PS, 65 Newton, standard pull. Compute the pull correction in millimeter if during measurement the applied pull is 40. So PA is 40. Ha? Paano nakuha yung ML sa number 2? 865.30 divided by 1 minus 1.972 times 10 raised to negative 4. You can factor out ML here. And then divide both sides by this. Gets? Okay. 65.30. Yeah. Okay, going back. So 40 Newton. Applied force. Applied pull. The tape has a cross section of 3.18 millimeters squared. So that's your A. Cross section. 200 GPa. So this is a steel tape. If the measured length is 865.30, what is the correct distance? So again, measured. Yeah. So first, let's compute for correction due to pull. So let's look at the equation. It's PL over AE. So correction due to pull. And then remember, change in P is PA minus PS. So 40 minus 65 times L. L is 100 meters. Now, we want our answer in millimeter, correction in millimeter. Okay? Ayan, correction in millimeter. Therefore, I need to convert 100 meters into millimeters. So just multiply this by 1,000 meters to millimeter. Okay, so I'll write that here. 1 meter is 1,000 millimeters. Then over area, it's given in millimeters, so no need to convert. And then GPA. So this is Newton millimeter, that's MPA, right? Newton millimeter squared. So I need to convert GPA to MPA. And to convert GPA, so 1 GPA equals 1,000 MPA. So we can just write this as 200 times 10 raised to 3 for 1,000. Okay? So please compute what's the answer. Very good, Ruben and Joe Schill. So Reyes and Ramirez. Negative 3.93 or 3.93 mm too short, or just right short. Okay? So again, similar to number 2, this negative sign just means there's a deduction in the actual length of your tape. Okay, so that's the first part. Next, part B is looking for the actual correct distance between 2 points. So TL. Once again, this is tape too short and we're measuring distance, so we need to subtract. So minus C ml over L. So TL, ml is given 865.30 minus, this is already negative, so just copy 3.93. And then, our measurement is in meters, right? This is in millimeters. So I need to convert that to millimeters first, to meters first. So again, 1 meter, 1,000 millimeter, to cancel out the millimeter. And then times ml over L. Again, I converted it because 3.93 is in millimeter. Our distances are in meters. And then this is 865.30 over length of tape, 100 meters. Okay, please solve. What's the answer? Correct. 86.26. Correct, Anthony and Lance. Canon. Again, please solve so we can check if we made a mistake. So 865.30 minus 3.93 over 1,000. 865.30 over 100. 865.266 meters. So here's a tip for you guys. Use the store function of your calculator. Okay? So 3.93, the whole value of that store, and you're gonna use that stored value here to get 865.266. Okay? So use the store value of your calculator. Okay. So that's number 3. Any questions so far? Please answer in the chat for numbers 1, 2, and 3. How about the others? Please answer. If you don't have questions, just type none. None po. Clear po.
Ma'am, bakit po convert yung GPA to MPA? Bakit mo convert yung GPA to MPA?
So 1 GPA is 1,000 MPA. So this 200 GPA, so you multiply it by 1,000. And I just like to write it as times 10 raised to 3. So this could be 200 times. So 1 GPA is 1,000 MPA. So this is the same as writing 200 times 10 raised to 3. Okay? So I'm just making a shorter version. Okay, number...
Ano po yung ibig sabihin ng GPA pati?
Anong ibig sabihin ng GPA?
Opo.
Okay. MPA is meganewton per meter. GPA is giganewton per meter. So that's your unit for modulus of elasticity.
Ma'am, question po.
Yes?
Ma'am, bali po ba ma'am, i-disregard po yung sign? Kasi po dun po sa C sub P, yung correction po, negative 3.93. Dun po sa formula ng TL po, bakit po hindi siya nag-minus-minus po? Kasi
Ah,
since negative 3.93 po.
yeah, you just disregard it in the equation because this negative sign just means it's shortening. Okay? And we know if we're shortening it, we're subtracting the value of your correction. So minus the value only.
Thank you po ma'am.
Okay? And so take note of that. Try not to mix this up. Again, this negative sign for both number 2 and number 3. And this just means it's gonna be contracting. So shortening. And when we shorten and then measure, or if your tape is too short, or if your tape contracts and we want to measure, we're going to subtract TL and ML, right, here in this equation. So subtract. So just subtract the value. So minus this. So in short, you can just ignore the sign when using it in your equation. Okay, any other questions?
Bakit po pala, no? Mega Newton ginamit instead of the normal Newton?
Newton, because our force is in Newton. This is in giganewton. So I had to convert it to Newton again. GPA. So GPA, MPA, PA, Pascal, that's your Newton per meter. MPA is either meganewton per meter or Newton per millimeter. GPA is giganewton per meter. 1 giganewton per meter is equal to 1,000 meganewton per meter. So that's why I converted it to MPA, because Newton millimeters are the units for this equation. So this is in Newton, Newton, meter should be millimeter, millimeter, Newton millimeter after converting. Okay, does that answer your question?
Yes po, ma'am. Thank you po.
Okay. So take care of your units. Make sure it's uniform before you start calculating, and apply the appropriate conversion. Okay, since no more questions, let's have number 4. Okay. A 50-meter steel tape weighing 1.75 kilograms is constantly supported at mid-length and its endpoints and is used to measure line AB with a steady pull of 6.5 kg. If the measured length is 1349, determine the correct length of AB. Okay, I'm gonna write down the given. 50-meter steel tape, that's your L. Length of tape. Weighing 1.75 kilograms. So let's write that as your weight. Supported at mid-length. So let's try drawing that. So mid-length and at the ends. So it's going to be supported here. Okay, and then this is 50 meters, your 50-meter tape. Therefore, these are 25 meters respectively. Okay, so that's the situation of your tape. Steady pull of 6.5, so your P, kg, and then measured length, ml. 1348. 1349.60. Okay, that's all you're given. And then finally, correct length of AB. We're looking for TL. Before we look for TL, okay, based on number 4, what kind of correction are we looking at? Or what type of correction is this? Correct. It's due to sag. So correct error. Alexandria, Arendon, and Geraldine. Lazaro, Arendon. It's due to sag. Therefore, the equation that we need is CSG equals W squared L cubed over 24P squared. Sag W squared L cubed 24P squared. Okay. So W, again, looking at definition, W is weight per linear meter. This is total weight. So to do that, that's 1.75 over total length, which is 50. So that's your weight per linear meter squared. And then L, again, look at the definition. L is unsupported length of tape for correction due to sag. So I'll rename this as length of tape, okay, LT. And then L is unsupported length of tape. So can you give me what is the value of your unsupported length of tape? L. Correct, it's 25, not 50. So correct. Alexandria and Michael Asador. Okay, it's 25. Okay, again, L is unsupported, and as you can see in our figure, 25 meters is the unsupported length. And then over cube, 24P is 6.5. Now you might be wondering, this is kilogram. That's not pull, that's not force. Force is Newton. But our weight is also in kilogram. So that's fine. I don't need to convert. Because if I do, so converting mass, this is mass, to be more specific or accurate, I'll just have to multiply it by 9.81, your gravity. So if I multiply this by G and then by G, as you can see, they're both squared. So the 9.81 squared will just cancel out. That's why I'm not converting anymore. Okay, and that's only because they're both in kilograms. If one of them is in Newton, one of them is in kilogram, then you have to make sure they're uniform in units. So convert one to Newton or convert the other to kilograms. Okay. And then please solve. What's the answer here for CSG? 4 decimals. Correct, Kian? Kiben and correct, Jasper. Viernes, Kiben. Okay, so 0.0189. Again, store this in your calculator to make our answers more accurate. And then, okay, so this is the correction for every 25-meter length of unsupported tape. Okay, and then we have this 1349.60. And then at the end, there's like a partial length wherein our equation won't apply. So that means I can't just do TL equals ML plus or minus C ML over L, and then just input this total ML here. No, we're not gonna do that. For SAG, you have to account for every full meter length that we have. Okay, so to get the full, how many times you get a full meter length. So the full meter length is 25 meters. So for every 25 meters, calculate what's the total length. Okay. So in short, how many times does 25 fit into this? Okay. No. How many times does 25 fit into 1,349.60? Correct, Mark. Villalobos. So we get 25 meter lengths 53 point something times. So that means, so 53.98. Okay, there are 53 25 meters in 1349.60. Okay. Therefore, getting the total length for your full tape lengths of 25, 53 times 25, that's 1325. Right. Yeah. So this is what we'll use first. Okay. So ml. So let's solve for the total correction for this part first. So let's call that C1. Total correction is this. It's this term. C times ml over L. That's a total correction for your total tape length or for your measured tape length. Again, for this case, we're doing 1325 first. So CSG times 1325 over, and we're using 25 meter length, so over 25. Please solve what's C1. Correct, it's just 1. So correct, Ruben and Angela. So again, store that because that's 1.00 something. And then you're gonna measure for the remaining tape length. So the remaining would be 1349.60 minus 1325, and that's 24.6 meters. So now I'm gonna need the correction for 24.6 meters. So that's C2, and that's just CSG times 24.6 over 25. Please compute what's the answer here. Correct, Michael and Colleen Sante. 2 points coming. And then Kian, Kiben, Sante. Zero point 019. And again, store that. And then to get the total length, that's your measured length. Okay. So our tape, remember for sagging, that's always subtract. So just minus. So minus C1 minus C2. Okay, please compute for the final answer. Correct, Jericho and Celica. Laguno Angel. Oh, sige, wait lang. 1, 3. So, pa-explain nung C1 and C2. Okay. So, for SAG, you have to determine first how many full meter tape lengths or unsupported tape lengths there are in your measured length. So to do that, just divide 1349.60 by 25. You'll get 53 point something. Take the whole number, so that's 53. Multiply 53 by your unsupported length, so that's 25. So you get 1325, meaning 1325 meters is the total length in which you have full 25-meter unsupported lengths. And then just solve for C1. So C1 is CSG, your correction, 0.0189 times that total length over 25. Since we're counting how many 25s there are in 1349. So you get 1.0004. Next, you're going to compute for the remaining tape length. Total is 1349.60. We already solved for the 1325 portion. So just get the difference of that. You get 24.6. So just do the same thing for this length. C2 is CSG times that length, 24.6. And again, we're using 25, not 50. 25 because we need the unsupported tape lengths. And you get that. And then correction due to sag is always subtraction. So you get ML minus C1 minus C2. Okay? Okay. And then let's have number 5. Number 5, slope distances AB and BC measures 450 and 1005 respectively. Difference are that for AB and 3.6 for BC. AB is rising, BC is falling. Determine horizontal distance from A to B. Okay, let's, instead of writing out all of that, I'm just gonna draw it because it's easier to see. So AB, BC, AB is rising. Okay, so AB. BC is falling. Okay. Next, elevation of AB or difference in elevation for AB is 5.3. So that's this length. And that's the distance in their elevation. So this is 5.3 meters. And then for BC, it's 3.6. So that's less than 5.3. That's somewhere here. So your line BC should end here. And then this is 3.6. And what are we looking for? Distance from A to C. Okay. So just looking at this figure, let's call this line 1. Or the distance 1, distance 2. We want to get the total distance between C. So total distance D is just D1 plus D2. Now, without looking at your equations, okay, just using your previous knowledge from all of your math classes, can anyone tell me how to get D1? Ay kulang. 450.60. And may length dito eh. Then this is 1,000. Okay. Oh, very good, Michael, Ardiel, Viernes. Michael, 2 points ka na. So, Ardiel, Lapid, correct. Very good. And then, Viernes. 2 points ka na din. Anyone else? Kian, 2 points ka na din. So, Astada. Okay, correct, Kurt. Okay, it's Pythagorean theorem. Very good. If you've noticed, we have right triangles. So that's Pythagorean theorem. So to get D1, please compute. Later, wait lang. Okay. Square root of hypotenuse squared minus leg squared. Please solve. What's the answer here? Correct, RDL and Vince. So, Perlas Lapid. Okay. It's 450.57 against OR. And then do the same thing for D2. D2 now is 1005.81 squared minus 3.6 squared. Please solve. What's the answer? Correct, Joey Reyes. And
Joshelle
Luigi.
po, Miss.
Joycel?
Joshelle po.
Joshelle. Okay, thank you. Okay, Joshelle and Luigi. So Ramos and Reyes. Okay. It's 1005.80 against OR. And then total distance is D1 plus D2. Please solve. What's the answer? Correct, Colleen. And Luigi Ramos. It's 1456.37. Okay, that's it. So that's just using prior knowledge in mathematics. Okay. So why do we have a correction for slope here? Well, we can use that as well. So let's solve for C1. C1 is h squared over 2s. H is difference in elevation. So let's call this C1. So that's 5.3 squared over 2. And S is slope distance. So that's 450.60. Please solve. What's the answer here? Correct. 0.031. Correct, Jericho and Angela. Katigalan and Tagulo. Okay. So it's 0.031. Okay, I'm gonna solve this on my own since we're almost out of time. So please just listen. So this would be 3.6 squared over 2 times 1000. Again, I'll just solve this on my own, so just listen. Okay. 6.44. Okay, so TL would be TL1 plus TL2. TL1 is ML minus, and ML is 450.60 minus C1 ML over L. Okay, there's not a given for length of tape. Okay. Okay. 450.60. Okay. So TL. So here, if we're using slope, TL1 is just ML minus C1. Okay. So alpha A minus ML is 450.60 minus C1. And that is 450.57. And then TL2 is just ML minus C2. So there's no more times ML over L. So that would be 1005.81 minus C2. And C2 is so 1005.80. So TL1 plus TL2, if you try to solve for that, you'll get 1456.37 meters. And as you can see, it's the same answer as the previous one, but one solution is significantly shorter than the other. Okay, so this is an example of how knowing previous topics in your mathematics or physics classes can help you create a shorter solution or easier way to understand the problem. Okay, so that's numbers 4 and 5. Any questions? Please answer in the chat. Okay, question. Will there be an issue if we round off in the end? Like mama, yes. So I want you guys to get in the habit of storing your values in your calculator. Okay? And then only round off for the final answers. So store your values or else you won't get the correct answer in your examinations. Any other questions, concerns? None? Okay. So I'm gonna end it there. Next meeting we'll answer 6 to 7 and accidental errors. And on Saturday, it's a holiday, right? So there's no meeting on Saturday, no activity on Saturday as well. So I'll see you on Tuesday for our lecture.
Ma'am,
Yes.
upload niyo po yung slides pati yung nandiyan po sa Photoshop na sinulat mo.
No, I won't be sending this. I will be uploading the recording of this lecture though, of this session. I upload the copy of your lecture over here. It's not there. That's field. Okay. Oh, not this. Ayan. So it's over here. Distance measurement. But I won't be uploading your my solutions. I will upload the recording of this lecture though. Okay. Then yes, what's the question about the PDS? By the way, tomorrow we have fieldwork meeting at 12 o'clock. Yes. For your preliminary data sheet, you can round off your answers to 2 decimal places in the table. Remember, submission of preliminary data sheet is on Friday. We have a meeting tomorrow as well. But you may
Ma'am?
do your, yes?
Yung preliminary data sheet po ba, yun nasa fieldwork 1 na file po? Yung
Yes.
nasa ibaba po? Hindi po kasama yung guide questions, di ba ma'am?
Hindi pa. You
Sige
don't
po.
do that.
Thank you po ma'am.
Okay, you're welcome. Guide
Dun po
questions are
sa
only for the report.
dun po sa computations, ma'am, pwede po screenshot na lang yung na written na equation tapos attach as picture dun sa file? Or dapat po dun po mismo sa file i-edit?
Yeah, no, I need dun mismo sa file nakalagay yung computation. So you're gonna submit one file to me only, including the table,
I know,
sample computation, and sketch.
I mean, ma'am, picture na lang po yung
Yeah, you can just take a picture.
solution.
Yes,
Okay po.
you can take a picture of the solution. So it's here in the field under week 1, submit it here. Fieldwork preliminary data sheet. This is your class value. You'll use this to complete your data sheet. And this is your peer assessment. Everyone will do that. And then just watch this demo video to do your fieldwork 1. Yes. Bakit sa ML-C1 disregarded C times ML? Yes, because there's no length of tape for slope. The adjustment is already for the total length. It's not per tape length. That's why it's disregarded. Tapos, time, weather, location, you can just ignore that since we're not really doing this field work. In your preliminary data sheet, you don't have to write time, weather, location. Yes, for sketch, you can just draw 2 stickmen holding the tape. Up to you how pretty you want to do that, but that's the sketch. Yes. So for the PDS, yung picture, ginawang computation sa paper, then attached sa PDF as photo, yes, you can do that. And then sketch, someone asked about sketch. Yeah, you were gonna sketch point A to B. Ano pong ibig sabihin ng sketch sa data sheet? Yeah, you're just gonna sketch what happens in the fieldwork. So if you watch the video, I said their sketch could be just 2 people holding the tape. Sorry, your face factor pala to. First sketch, you can just draw a person walking. So that's for fieldwork 1. In some fieldworks, you need a figure. So you're gonna draw a figure to compute for your values. You can do that as well for your other fieldworks. For fieldwork 1, you can just draw people walking. You can draw your points, point A to B, and how many steps you took to get to point A to B. No, don't include guide questions in the preliminary data sheet. All I need is the table, the computation, the sketch. Okay, I'll give you an example of data sheet. Okay, wait lang. And that's a data sheet. So you have your table, your sample comp, your sketch. And that's the only thing you send me. Okay? All right, it's 3 p.m. I'll dismiss you guys. See you on Tuesday. You may go. Goodbye, class.
Thank you po ma'am.
You're welcome.
Thank you po, ma'am.